Hi, everybody. We're here for our first virtual science online lesson. And what you need to do, just like in class, you'll need to grab your science notebook if you happen to have it and a pencil. If you didn't bring your notebook home, that's okay. Just grab a piece of paper and a pencil, something that you can write on, and you can kind of save it as your science notes, just like you would at school. So go grab that real quick. Put this on pause if you need to. And while you're doing that, we're going to start off with a little bit of a review from what we did before the coronavirus happened. Okay, so I'm going to share my screen with you. So hold on while I do this. It'll just be like in class. So you may remember this. We started off with chapter 3, which was about stars. And what we worked on is we learned that there were 4 main differences in stars. The first one, if you remember, was size. And we watched that really cool video about how small and how huge the planets are. The next thing, oh, here's our other one showing how small we are compared to some of the stars. Then we learned that the temperatures of stars are different. Some are really hot, really, really hot, and some are just average hot, but they're all hot. Stars come in different colors. As we know, their Betelgeuse is a different color than Sirius, and our sun is a different color. And the last one was how bright the stars are. They come in different magnitudes or brightness. Now, we already wrote those 4 things down, and we talked about those. The next thing that we went on and did is we made this chart in our notebooks. And you don't have to write any of this because you should have it or remember it, that the temperatures and the colors of the stars go together. The hottest color, I'll put my mouse right over here, is the blue star. And Rigel is an example of a really hot star. Then we go to blue, white, and white. And here's our sun right here. Our sun is just an average star, and it's yellow, okay? Now, these other 2 stars down here are cooling down. The first one is an orange-red star like Arcturus. Arcturus, I hope you remember, is in Boötes. And then the coolest of them all color is red, and that is Betelgeuse. Betelgeuse is a dying star. It's cooling off, and it's a red color. So the temperature and the colors go together. If I asked you what color a cooling star was, you would be able to say red, okay? So that's what we did a little bit before we went on break. Here's a couple of facts I wanted you to know about stars before we go on. And you don't have to remember or write any of this down, but all stars make their energy and their heat and their light by starting with hydrogen. Hydrogen then explodes into a gas called helium. So those of you that did our big planets like Jupiter and Saturn and Neptune and Uranus, a lot of you will remember that they have hydrogen and helium also, but they just weren't quite big enough to get started as to being a star. Our sun then started with hydrogen, and it blows up, those big explosions like you can see in this picture right here, and those explosions create the heat and the light. Now, because objects in space are so far away, we don't use kilometers and miles when we do them. We use a unit called a light year. Because they're so far, we imagine writing a huge, long number, how many miles things are in space. So scientists say light years away. And a light year is how far it takes light to travel in 1 year. Now, light is the fastest moving object that there is. Light travels at 186 miles per second. Think about that. In one blink, blink your eyes, blink. Light has already gone 186,000 miles per second. So we think going 70 miles an hour is pretty fast in a car, but light is the fastest traveling thing that we know of. And so when we see stars that are way out in space, they are light years away from us. And we measure that in how long it took that light to travel to Earth. Okay, so those are just 4 facts that you need to remember. Stars burn hydrogen into helium, and distances in space are so huge that we call them light years away. All righty. So here's what we're going to do today. We are going to talk about the life cycle of a star. So here's where you need to get your piece of paper and your pencil out and write at the top, life cycle of a star. So we're going to learn how stars are born and how they live and how eventually they'll die. Okay, life cycle of a star. If I go too fast, you can always put this video on pause while you're writing it. Okay, so the first thing you're going to do is we're going to draw a diagram for this. And you're going to start the diagram way over here on this side of your paper. And you're going to make this lump, lump, lump that looks like this, like a cloud is coming off the side of your paper. And that cloud is called a nebula. And a nebula is a huge cloud of dust and gas. Huge clouds. They're not like our clouds that are floating around the earth. These are huge clouds, and they come in all different colors, and they're beautiful. And I'll put up a link tomorrow for you to see some really cool pictures of nebulas. So it all starts in this nebula. It's kind of like when your mom went to the hospital to have you. She went to the nursery, or she went to the baby section of the hospital. Well, a nebula is kind of like the area in space where new baby stars are born. So a nebula is a huge cloud of dust and gas. Remember, if I go too fast for you, then you just need to put it on pause and write it before I go on, because I can't make the videos too long. Okay, so out of that nebula, this huge cloud of dust and gas, we have these new little baby stars called protostars. So what I'd like you to do next is to draw an arrow like this coming out. Don't go too far because we need to use our whole paper. So you're not halfway across the paper yet. Draw this lumpy thing that looks kind of like a cotton ball and call it a protostar. A protostar is a baby star. It's just forming. It doesn't have all of the power of a star like our sun yet. It kind of flickers off and on as it's starting to go. It's gaining its energy. And a protostar grabs the energy, the hydrogen that it needs out of these clouds called nebulas. So a protostar can be a baby star for quite a while. Okay, it takes millions of years for this to happen. Don't think it just takes a couple of days. So first comes a protostar or a baby star. And when finally that protostar can shine all on its own, we say it is officially a star. So if you draw a little arrow coming from the protostar and make yourself a star and label star underneath there. When a star like our sun finally can shine and it's not flickering at all, it becomes a star. It has enough hydrogen to turn into helium that it can shine brightly, and it's called a star. Okay, now some stars are born really big and some stars are average like our sun. We're going to talk about what happens next and how these stars are going to end their lives. Now a star can stay a star for millions and millions and millions of years. Our sun is only about halfway through its life cycle. It has a long time left to live. So what happens next with this star is when it begins to die or begins to run out of energy, it cools off. So I'd like you to draw this big circle. Now you should be about halfway in your paper. This big circle around there. And inside the circle, write red giant or super giant. Now our sun, when it cools off, it's going to turn into a red giant. It's going to get bigger and bigger and bigger because it's going to cool down. And as it runs out of the hydrogen, it doesn't have as many explosions anymore, and it's going to swell out to about almost to Jupiter. So it'll suck in all of those planets in there as it swells. Now remember, this isn't going to happen for millions of years. If it was a big star like Betelgeuse, Betelgeuse was a big star to begin with. It's going to swell up like it is doing now, and it's called a supergiant. What happens then as the star cools off, it begins to swell, kind of like if you put water in the freezer, and as it cools off, it swells and gets bigger. Like, don't ever put a can of pop in there because it could explode. So these stars do the same thing. They get bigger and bigger and bigger because they're cooling off. Now we're going to talk next about what happens if it was a really big star, how it's going to swell up. Now this is what's going to be happening to Betelgeuse. Okay, so draw a little arrow off the top here and call it a massive star. Right inside that arrow. Massive means really big. Like if you have a massive headache or a massive test, it means it's big. If it's a massive star like Betelgeuse, it's going to get bigger and bigger and bigger until finally three things could happen. Okay, these are the three things that could happen. Let me move my picture down here. First of all, it could turn into a black hole. As it explodes, we call that a supernova. So as this Betelgeuse, or a big star like Betelgeuse, gets bigger and bigger, it's going to just explode into a supernova, which means a huge, huge explosion. Super bright, brightens up the whole universe. Okay, and so the supernova happens. It can form a black hole, which is a very mysterious thing. Kind of turns in and becomes like a vacuum, sucking things into it. Or it can become a neutron star. A neutron star twirls around itself, and it can still be bright, but it's much smaller and dense in size. So Betelgeuse could be turning into having a supernova, creating a black hole, or a neutron star. Okay, now the next thing that could happen is, let me go to my next slide. If it's a regular star, this is how our sun's going to end its life. So make your next arrow there, right, regular star. And this is how our sun's going to end its life. Not as exciting as bigger stars do. So our sun is going to run out of energy. It's going to then shrink back. It's kind of like blowing up a balloon and blowing it bigger and bigger and bigger. And instead of exploding like Betelgeuse is going to do, our sun's going to get bigger and bigger and bigger. And then it's kind of like if you just let the balloon go and the air goes, and our sun is just going to go, and it's going to be turning into what's called a white dwarf. It'll be much smaller. It'll still shine a little brightly, not very bright at all, but it'll kind of shrivel back down. And when that gas is all used up, the last stage of our sun's life, we call it a black dwarf. So when you make your black dwarf, do these little dot, 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 dots, because there's really nothing there. It's just a little bit of gas that's left, and that's a dead star. So our sun is going to get bigger, shrink, and then fizzle away into just a little bit of gases left that we call a black dwarf. So now you know the life cycle of a star. Okay. Let's go back here. And we'll escape out of that. Go back to our video. And that is where we are going to stop for today. See you next time.